In 2017, a lorry weighing nearly 25 tons drove straight over this watch, and the watch just kept running. No cracked glass, no stopped display, still keeping time to the second. Now, here's what everybody assumes: that it survives because it's built like a tiny tank. Thick, solid, stuffed with rubber. And that's almost exactly backwards. The G-Shock survives because deep inside it, the brain of the watch, the delicate part that actually keeps time, isn't bolted down to anything at all. It floats in a hollow space, barely touching the walls around it. And the engineer who worked that out only got there after smashing more than 200 watches to pieces, throwing them one by one out of a bathroom window, and very nearly quitting his job in despair. So to understand how a wristwatch shrugs off a lorry, we need to crack 3 questions. 1. How does letting the brain float loose inside the watch make it stronger and not more fragile? Because that sounds insane. 2. If it isn't just thick rubber, what actually stops the shock? And 3. Is it really indestructible? Or is that just marketing? And what does finally break one? Stick around, because by the end we'll come back to that lorry and you'll understand exactly why it didn't win. The principle: isolate, don't armor. Let's start with why this is even hard. Because a digital watch, for all its toughness on the outside, hides one desperately fragile part. It's called the quartz oscillator, a tiny vibrating crystal that keeps the time. Give it a hard enough knock and it cracks, or a solder joint on the circuit snaps and the watch simply dies. So, the whole problem of a tough watch comes down to one thing: protecting that little crystal. And here's the trap. The trap our engineer fell into for 2 solid years. The obvious answer is to wrap the crystal in protective material. More rubber, thicker padding, armor it. But it doesn't work, and the reason is beautiful. A hard impact sends a shockwave, and that shockwave travels straight through solid material. Pad it all you like. The wave still arrives at the crystal. Worse, to absorb enough shock this way, the watch swells up to the size of a tennis ball. Unwearable. So here's the idea that turns this whole story around. The breakthrough wasn't a better way to absorb the shock. It was a way to stop it reaching the crystal at all. Instead of gripping that fragile brain tightly, you let it float, suspended in a hollow space, touching the walls at only a few tiny points. If the shock has no solid bridge to travel across, it never gets there. Less contact, more survival. Think of protecting an egg in a box. You don't do it by packing the box solid with stone. Drop that and the egg still shatters because the impact travels straight through the packing. You protect it by suspending it in the middle, barely touching the sides, like a yolk held in the middle of the white. That floating egg is the whole secret of the G-Shock. Or think of a boxer taking a punch. A good boxer doesn't meet the fist rigidly. He rolls his head with it, letting the force slide past. The loose floating module rolls with the impact instead of taking it square on. And the man who finally saw this saw it in a children's playground. When a rubber ball hits the ground, the outside deforms violently, but the very center of the ball barely feels a thing. He looked at that bouncing ball and thought, what if the brain of the watch could be the center of the ball? A point the shock never really reaches. That man was Kikuo Ibe, a young engineer at Casio in early 1980s Tokyo. The whole thing started when a watch his father had given him fell and shattered on the pavement. At a time when Japanese fashion wanted watches as thin as possible, Ibe proposed the opposite, a watch that simply would not break. He formed a 3-man group he called Project Team Tough, chasing a target he named the Triple 10. Survive a 10-meter drop, resist 10 bar of water pressure, and run for 10 years on 1 battery. 2 years and more than 200 broken prototypes later, with the project on the edge of cancellation, that bouncing ball saved it. But a ball is just an idea. And an idea doesn't stop a lorry. To do that, eBay had to turn let it float into an actual system. And that system, in the very first G-Shock, had roughly 10 layers. Let's walk through them, from the outside in, following the shock on its journey towards the crystal, and watching it die on the way. The bumper that takes the first hit. The shock's journey starts the instant the watch hits the ground, and the most vulnerable spots are the ones that stick out. The glass, the buttons, the corners. So, the outermost layer is a thick urethane case and bezel, the soft, grippy outer shell. And it's not just a lump, it's shaped deliberately. The bezel stands proud of the glass, and the surface is knobbly and uneven, so that whichever way the watch falls, a bit of tough urethane hits the floor first, keeping the glass and the buttons from ever slapping flat against a hard surface. That's why a G-Shock looks the way it does. That chunky, armored, slightly ugly shape isn't styling for its own sake. Every bump and ridge is a part designed to take a hit so something fragile doesn't. Form born entirely from function. It's the crumple zone and the bumper of a car, or the roll bars on a race car. The sacrificial bit that touches first. So, the outer shell takes the blow. But the shockwave doesn't stop there. It travels inwards through the structure, heading for the crystal. So, how do you stop it crossing the gap into the module? The floating module. This is the answer the whole watch is built around. Inside that case is a hollow space, and the module, the timekeeping brain, is not screwed down into it. It sits in a cradle of urethane foam and touches the surrounding case at only a few minimal points. It floats in the hollow, almost suspended in mid-air. And here's why that matters so much. A shockwave needs something solid to travel across. By cutting the contact between the case and the module down to a handful of tiny points, IB removed nearly all the bridges the shock could use. The blow lands on the case, and then finds almost no path onwards to the crystal. It arrives at the edge of the hollow and just stops. And this is the moment I want you to sit with, because it's the opposite of common sense. Reducing the contact protects the module more than adding material ever did. For 2 years, eBay made the watch tougher by wrapping it, and it kept failing. The instant he did the reverse, let go, and let it float, it worked. He wasn't protecting the brain by holding it tighter. He was protecting it by barely holding it at all. The floating egg again, suspended in the middle of the box, touching nothing it doesn't have to. And remember how he tested all this. There was no fancy lab rig at first. eBay would climb to the 3rd floor bathroom at Casio's R&D building, open the window and hurl the prototype down onto the concrete about 10 meters below. Then pick up the pieces, work out what broke, strengthen it, and throw the next one, over 200 times. But a floating brain has a problem of its own. It still has to talk to the outside world, the buttons you press, the display you read. And every rigid connection you add is a brand new bridge for the shock to sneak back across. The interfaces that flex. Take the buttons. If you connected each button to the module with a solid steel pin, you'd have just handed the shock a perfect little road straight back into the brain. So instead, the buttons press on the module through what are called oblong button shafts, connectors shaped and mounted so they flex and give, rather than transmitting a blow directly. Press the button and it works normally. The movement passes through. But knock the button in a fall, and the shaft simply bends and swallows the jolt instead of ramming it into the circuit. The connection does its job without becoming a weak point. It's a door handle mounted on a spring instead of a solid rod. You can still use it, but a hard whack goes nowhere. Add all of these defenses up, and the original G-Shock stacks around 10 separate layers between the outside world and that little crystal. Outer bumper, floating module, flexing buttons. But there's one last place the shock can do damage. Inside the module itself, where the crystal and the solder joints can still rattle. The ball inside the ball. So the final trick is to protect the crystal individually, right at the core. Inside the module, the quartz oscillator and the other critical parts get their own little cushions. In modern G-Shocks, that includes a remarkable material called alpha gel, a soft silicone gel that behaves almost like a solid liquid, squashing instantly under a blow and soaking up the energy before it can snap anything. It's a ball floating inside a ball, floating inside a case. And the result is measurable. Modern G-Shocks are built to shrug off centrifugal forces of up to 15 G in a test called ISO 2669, and that's not a watch standard, that's a standard written for aircraft equipment. Casio tests these things the way you'd test an instrument bolted into a fighter jet. So, add it all together. The bumper that hits first, the module that floats, the buttons that flex, the gel that swallows whatever's left. The shock crosses 10 layers, and by the time it reaches the crystal, there's simply no force left. And that is why a 25-ton lorry can roll straight over it, and it carries on telling the time. Which brings us to the obvious question. If the shock dies before it ever reaches the crystal, is there anything left that can actually break one? And the honest answer, the one Casio's own adverts got into trouble over, is more interesting than a simple no. Connection, the ad nobody believed, and the honest limits. First, this idea is all around you. The exact principle inside the G-Shock, don't stop a force dead, isolate it and spread it out over time, is doing quiet work everywhere. It's the airbag and the crumple zone in your car. It's the foam in a bike helmet, which crushes so your skull doesn't. It's the way a new phone sits suspended in its packaging instead of pressed against the box. It's the landing gear of an aircraft and the anti-vibration mounts under heavy machines. There is almost certainly a floating module of some kind within a meter of you right now. Now, the drama. Because at first, this watch was a flop, and the story of how that changed is my favorite part. In Japan in 1983, the G-Shock barely sold. It was big and chunky in a country obsessed with slim, elegant watches. And there was a stranger problem. Watch shops didn't want it. As eBay himself recalled, repairs were good business, and a watch that didn't break was bad for the bottom line. Then, in the mid-80s, Casio's American arm ran a television advert showing an ice hockey player using a G-Shock as a puck, whacking it across the ice with a stick. And the public reaction was flat disbelief. No watch could survive that. Casio was accused of faking it, of false advertising. So a Consumer Affairs TV program set out to catch them in the lie. They'd repeat the stunt live and expose the watch as a fraud. They took the G-Shock and they hit it, and it survived. The attempt to humiliate the watch put its toughness on live television instead, and sales began to climb, with firefighters, police, skateboarders, and the hip-hop scene all adopting it. The plan to destroy the G-Shock is the thing that made it famous. But let's be honest about that word indestructible, because it's marketing, not physics. The G-Shock is astonishing against one specific enemy: sudden impact and shock. That's what the whole floating system defeats. It is not magic. Crush it slowly in a vise, cut it, cook it, and it has limits like anything else. In fact, viewers who watched that live test recall that in one extra challenge beyond the advert, they shot the watch with a rifle, and that finally stopped it. True or not, the point stands. A G-Shock isn't unbreakable. It's brilliantly, specifically built to beat the one thing that kills ordinary watches: the drop. So, back to our 25-ton lorry. It didn't lose because the watch is a solid block. It lost because there is no solid block. Under that tire, the outer shell took the load, and inside, the brain of the watch was floating free in its hollow, connected to almost nothing, with no rigid path for all that weight to travel across and crush the crystal. The force pressed on the shell. The shell spread it out, and the little floating heart in the middle barely felt a thing. That's the whole secret. Not armor, not thickness. A brain suspended in space, protected by not being held. An idea a frustrated engineer found in a bouncing ball on the day he'd almost given up. And the idea keeps evolving, carbon cores that stiffen the case while shedding weight, solar charging, satellite time. But here's a thought to leave you with. The G-Shock beat the drop. Yet there's one invisible enemy that still ruins even a fine mechanical watch in seconds. Magnetism. How do you shield a watch from something you can't even see? That's a video for another day. So here's my question for the comments. What's the toughest thing your G-Shock has ever survived? Or, if you've ever genuinely killed one, how on earth did you manage it? I want to hear it. And if this changed how you see that chunky little watch, the subscribe button costs nothing and genuinely helps the channel. There's a card on screen for our breakdown of how a mechanical watch survives being magnetized, the invisible enemy I just mentioned. It's stranger than you'd think. Thanks for watching. I'll see you in the next one.